Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to explore the value of pi. For preparing this video lecture, I used Windows 10 operating system, licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be preparing. We will ask the children to explore the value of pi. We will be drawing a circle and a polygon inside, and we will tell them that the pi value will be 2 pi r by 2r. When I increase the value of it, suppose you are seeing that when I increase the number of sides of the polygon becomes very close to the circle. Here I have taken n is equal to 100. You can take n is equal to 2000, 3000, 1 lakh, whatever you want. Therefore, the circumference of the polygon by the 2 into the radius, when you are finding it, the value of pi will be approximately you will get. Now you can change this value of n also by doing the right clicking and go to the object properties, and you can make it into 1000, and you can come back, and you see whenever it is becoming 1000 you are getting more approximation for this, and you can move this also and then ask the children to check out what will be the approximate value of pi. Let us try to design this dynamic worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet, geometry view, and in option rounding off to 15 decimal place. As I told you earlier, we want a more approximation for pi, and this GeoGebra gives you up to 15 decimal place approximation for the value of pi. Here I have already taken the navigation bar. Therefore, in the text bar you can type explore, the value of exploring, value of, from the symbol you can take try. Okay, now let me draw one circle. I am not taking labeling of new points. Okay, I will take no new points. I am not taking labeling. Okay, now the circle I will take with the center, and I will take a point there. Okay, now I can join and get it radius also. Now by right clicking it, I can know that okay, this is f. Therefore I will keep it in mind that f is the variable for the radius. Well, I think I can move it and then make it small, big, or whatever I want. Okay, let me go for a slider. This slider is going to tell me the side of the polygon. Therefore I will start it with 3, because I want the regular polygon starts with equilateral triangle. For the first beginning I will go up to 100, and I will show you how it can be increased up to 1000, 2000, 5000, 10,000, and so on. Or I will click it as okay. Or when I move it, it is moving now. Okay, now I want to rotate this particular point on this here on the circumference with a degree, so that I will get equilateral triangle. Now at what degree you have to rotate it for equilateral triangle? It will be 360 degrees by 3. For if you want to have the square corners, it should be 360 by 4. Therefore what we will do is we will go for this rotation. Very interesting idea. Reflect about a line, reflect about a point, reflect about circle. Therefore we will take a rotate around the point. When you touch this, when you touch the center, it will ask you how much angle you want. Okay, I will put 360 upon n. Okay, small n, sorry, small n. I want it for equilateral triangle 360 by 3, for square 360 by 4, and so on. Therefore I will click OK. Automatically you got this point now. Now I will go and construct a equilateral triangle now. Therefore regular polygon, touch this one of the sides and one of the side. It will automatically ask how many vertices you want. I want to have it as n, because I will get a equilateral triangle now. Okay, I got it. Now let me check whether it works. Now you see it's going on. When I increase the polygon, it is automatically becoming a circle. You are seeing it now. For it becoming a square, then pentagon, octagon, then and so on. Okay, highly nice. Okay, now I want to tell the children that what is actually pi. For that, in the text box I will put a latex formula to the children, and I will tell them that the value of pi can be visualized like this. Latex formula, I will go for a by b. Then I will tell the children that it should be 2, then pi, then r, maybe r is the radius, divided by 2r. Okay, now the children will ask how I get this is 2 pi r. Now you can tell it is actually very simple. Therefore I will once again I am going for the latex formula. Pi is equal to a by b, sorry, is equal to symbol. In the a I will write circumference of, okay, now I think if you want to have a space, latex formula space, then here again latex formula space of the polygon by 2 times the radius. Therefore 2, in the symbol you can go and have this into radius. Okay, now we have to go for exploring now. Okay, now the children have got an idea now. Therefore when I go on increasing it, now the circumference of the polygon will become 2 pi r and divided by 2 into the radius. Okay, now we want the polygon circumference. Therefore go for this distance or length and then touch this. Okay, you got perimeter of poly 1. Let us see actually in that graphing what is the name given to it. Perimeter of the poly. Okay, here it is, perimeter poly 1. You have to be a little bit careful because GeoGebra is fixing its value as per its convenience. Therefore as per the formula you type it very simple in the input box, PERIMETERPOLY 1, that is the value, divided by within the bracket 2 times the radius, therefore it is f. Okay, please be careful with the spelling. It is the same thing, perimeter poly 1. Here also perimeter poly 1 divided by f. I am just putting the enter. Now it is coming as O. It is automatically taking it as O. Now please observe this O. When I am moving it, it is going very close to 3.14. You are seeing it, 3.14. It's very close. It goes now. Therefore, let us come back and then go to this geometry view. And now you can declare to the children that what is the value of pi now. Therefore, the value of pi is equal to, from the object, I think all of you have seen just now, it is O. Somewhere I have to find out, I think A, B, C, D, M and O. Oh, I think this is, no. Okay, I think small O it was, huh? Okay, from the object, you have to search it. From the object, search it. Yes, it is coming down very low. How many are there? Okay, you got it. Okay, and now this you can, this poly, if you want to show the object, you can hide it also. Now you can make it a little bit big so that the child can visualize it very large. Let me make very large. Okay, well, okay, I think very large is going outside. Therefore, let us have large. Okay, 2.56. Okay, now you can ask the children to come and check the value. It now, if you move it, you see it is going very close to 3.14. Now, what is the more approximation you can have? You can right click it, go to this object property. Very simple. In that 100, let me add one more 0. Okay, it is becoming 1000 now. Okay, going 3.14. Okay, escape. It is going. Sometime be careful. If you go beyond a certain number, there is a possibility of getting your computer getting hanged. Therefore, you should be a bit careful. Then move it, and then just tell the children that how it goes very close to 3.145, like that. You can go and tell them. For 1000, 2000, 5000, like that, you ask them to go on changing it so that they can get the value. Highly interesting. Therefore, when the polygon is going on increasing, then the polygon is becoming a circle. Therefore, the circumference of the polygon divided by 2 times the radius give you the value of pi. It is the meaning. Okay, now another interesting thing about it, okay, at 1000, I am moving the radius, I am just changing. Are you seeing only the last 3 digits are jumping? The remaining digits 3.1415, it is not at all changing. Therefore, this also the child can understand very clearly that how the pi has come from the circle. Circumference of the circle divided by 2 times the radius give them the value of pi approximately up to 15 decimal places. Thank you. Let us learn to lead.